Welcome to episode 2, friends. In this episode, the first topic is how we measure the distances of stars and galaxies. This is a very important thing, and this is a very bizarre thing for me also, that how we measure that distance, that this is 4 billion light years, this is 3 billion light years, dude. So, how we measure that? So, here's the trick. Edwin Hubble discovered a way to find astronomical distances like objects, stars, and galaxies. And how he do that? He actually what did not the objects emit light, and he measured the luminosity of the object and brightness of the object. And according to this formula, L equal to 4 pi d square b, he somehow managed to get this d value. You see d value, and here d is the distance. Here d is the distance. So that's how he did that. That's how we measure. And one more thing, that he managed to find distances of 9 galaxies through these methods. And there is one more method, which is called light spectrum method. And this is a very powerful method. Each star's light has its own unique spectrum. And what happens now, again, if we examine the spectrum of each star, we find some spectral lines, some wavelengths just missing, and they can tell the star's temperature, elements present in the star's atmosphere, and it is survivable or not, it has planets or not. Everything we can just tell by looking at the spectrum of light coming from the star. So what we learn that we find the distance of objects like stars and galaxies by measuring the brightness of light according to this formula, L equal to 4 pi d square b. Where b is brightness, L is luminosity, and d is the distance. So this is how we measured them. So now let's move forward. Now you might have heard Doppler's effect in sound. Let me introduce you Doppler's effect in light. So consider this scenario. This is object A, this is object B. Suppose this is emitting light in this direction, this is emitting light in this direction. And this object is traveling in this direction and this object is traveling in this direction. Well, means that they are emitting light in opposite direction and then the velocities are in opposite direction. So due to this velocity drama, what happens now, that wavelength shift occurs, like that in sound frequency changes or wavelength changes, and that shift, what occurs, is called red shift. Means that if two objects are moving away from each other and emitting light, then there must be red shift. And this exact thing Edwin Hubble found in light coming from two different galaxies. Thus he concluded that galaxies are moving away from each other, and so universe is expanding. In previous video I told that the universe is static or expanding. Yeah, we know that in current time that universe is really expanding, but that time Einstein also believed that universe is static. But this is a big discovery, that universe is expanding. And how we got that idea? That galaxies are moving far away from each other because the light coming from galaxies are red shifted. If red shifted, they must be moving away from each other according to this scenario. So let's move forward now. See, we know universe is expanding, so there should be some rate of expansion, and scientists realized that universe could not be static because it will eventually collapse under its own gravity. Same problem I told you in previous video, that it will collapse under its own gravity if universe is static. So it should be expanding or contracting. So now we know that universe is expanding. So this will happen if universe is static, na? Then the universe will shrink and there's a big explosion and everything that's doomed. Let's move to another topic, the critical rate of expansion. This is the rate of expansion. This is a very interesting topic. See, universe is expanding at a just rate, so that it will just not collapse, just like escape velocity of rocket. You have heard about escape velocity, that if at certain velocity, for Earth it may be 11.2 kilometers per second, that if we shoot an object towards the sky now, at a given angle also, I think it will not come to falling down to Earth, it will escape from Earth gravity. So this is called critical or escape velocity of that object. So universe is also expanding like that, and it is somehow preventing its collapse from gravity, just like expanding at some rate, so that it will not collapse. You get that, no? That's why it is called critical rate of expansion. Now here comes also a great scientist called Friedman. What a funny name, like a fried man. Let's respect him. As Einstein general relativity equation, so that the universe is expanding, but he added a cosmological constant to adapt the static model. Especially what I can say means, first he discovered that universe, according to his equations, what he was writing on paper, he concluded that universe must be expanding according to my equation. But all people say that it is static. So I must add some constant to prevent that, so that they will accept my equation. But this Friedman, what did he? He's a Russian physicist. He disapproved of cosmological constant. He just valued original equation and start working on it. And what he did, he assumed two things: that universe is identical everywhere from where we look, and from that what he concluded, that universe is expanding. And so somehow, after assuming universe is identical, he put a model of expanding universe in 1922 before the Hubble. So he predicted what Hubble discovered before. So what is written here, that original equation of general relativity of Einstein showed that universe is expanding. So somehow he solved the equation by assuming some things, and he printed the solution to the world and say that universe is expanding. What can you do? Universe is expanding. So, and he did that. I told you that Edwin Hubble discovered universe is expanding in 1929, but he somehow managed to do it in 1922. So he predicted this before Hubble discovered it. And about his assumption that universe is identical everywhere, that is not true now. On a small scale, where the Mars, Jupiter, Earth is not identical, but on a large scale, say galactic scale, two galaxies may be identical, cluster of galaxies may be identical. So on large scale, his assumptions may be some sort of true. This will clear in next point. In 1965, the assumption that universe is identical everywhere proved to be very accurate, because microwave radiation coming from different parts of universe is identical. See, the radiation which we receive from the explosion of Big Bang or from deep parts of universe is always microwave. And that microwave radiation, what in 1965, the scientists detected that, I think the name of scientist was Roger Penrose, I think some sort that the microwave radiation which is coming from everywhere in universe is identical. So he concluded that, and Friedman assumption is correct, that universe is identical, because radiations of wavelengths that particles were emitting were identical. So we can say that in Friedman's model, all galaxies are moving away from each other, just like a balloon. Suppose you have a balloon and you put some dots on it, and you trying to fill the balloon with air, and it will expand. And how it will expand? It will expand in such a way that dots in the balloon will move away from each other. Just like that, solved the Einstein equation and predicted that all the galaxies are moving away from each other, and the speed at which two galaxies are moving away from each other is directly proportional to distance. It also means that redshift is directly proportional to distance, and exactly what Hubble found. Means he predicted everything what Hubble found in 1922 only, but nobody is ready to believe that, because Einstein himself said that universe is static. So that is written in stone that universe is static. But somehow after discovery of Edwin Hubble, that he discovered not that the universe is expanding. How can you deny observable experiment? Means what we see is definitely true. What equations says might not be true, but what we see that galaxies are moving away from each other is definitely true. Na? Therefore, the expanding model of universe came to be correct. Now let's move to three model of universes. This is the best part. Let's dive into this. First model says that universal gravitational attraction between two different galaxies causes the expansion to slow down and eventually stop. That means what is saying now that it may happen that galaxies move away from each other, but due to somehow because of their gravity they will eventually stop and they will eventually collide. So everything in universe will collide and go down to big explosion, back to zero again. It means that universe will collapse due to its gravity. In second model, that universe is expanding so rapidly that the gravitational attraction can never stop it. Though it slow down a bit, eventually galaxies are or will be moving at steady speed. So this is what's saying that expansion rate is so huge that gravity will never be able to pull everything together at one point, so it will never collapse, but it may slow down the expansion and up to this extent that eventually bodies will move at a uniform rate away from each other. Means the velocity of moving bodies away from each other will be constant at a steady speed. What this means? Now let's go to the third model. Universe is expanding just fast enough to avoid the recollapse. This is what we call a critical rate. I told you before, a critical rate. Though this is the correct model. So it starts from zero to expand forever, but in the end, galaxies will eventually stop moving away from each other at infinite time. This model is what's saying that this may happen, that universe is expanding at critical rate and it's somehow at the infinite time and very far away from this time, that it will eventually stop expanding and just stay what is just like. Means they will stop moving away from each other, and and distances are so large that gravitation is so weak that they cannot pull each other. That this is what will happen now. If you means let's say you have two balls distance of 1 meter and then you change the distance to 1 light year, then how gravity can never pull those two balls together. So gravity can never recollect the universe, gravity cannot collapse the universe again. This is written, this is right, because the distances object will be so large that gravity will not be able to do that. Density of expanding universe. This is a very good topic. Density of universe should be enough to prevent from it recollapsing. Well, so basically density what called mass depends on gravity, so mass should be enough to just prevent the gravity to recollapsing. Means everything should not collide. But here is the twist. If we sum up all the masses of galaxies, stars, planets, everything, asteroids, it is only 1/20th of what is required to pull everything, to just put everything in what condition is right now. Means some mass, a huge amount of mass is missing. Means that they may be invisible matter, because density is not enough of universe. It is not equal to critical density what we calculated to prevent the collapsing. So maybe so there should be some sort of invisible matter present in universe, dark energy, dark matter, and how we prove that that dark matter exists if we can't detect them and if we can't see them. So the thing is that dark energy, dark matter, antimatter, whatever they are, their gravitational forces, their gravitational effects are visible on large scale, that they can affect the orbits of the planets, and they can affect the place of the planets also. The gravitational influence of them are visible. So that's why we conclude that there should be dark matter, and dark matter consists of dark matter and other types of matter maybe consists of 95% of the mass of universe. So that's how it is. Now what about Big Bang? All model of universes we told you now, three models, suggesting that there should be some sort of beginning kind of thing should be present in the past called Big Bang. Everything started from something, so it should be started from something that and what we assume that it started from infinite density and a very small length object, very tiny object with infinite density exploded, and where space time began and expanding universe began, and that object through which universe began is called singularity, or which we call now black hole. Black hole is a singularity. And what happens at black hole or singularity? That density is infinite and space-time curvature is infinite. Why space-time curvature is infinite? Because space-time is dependent on mass. I told you before. So if mass density becomes infinite, mass becomes infinite, and if mass becomes infinite, space-time curvature becomes infinite. And if space-time curvature becomes infinite, we cannot have laws. We did not have laws to predict what happens as space-time curvature infinity. So we cannot study that. Therefore, we cannot study black holes still. But some sort of physics started developing now, only with the help of Stephen Hawking, very great scientist. So what happens in Big Bang? That universe exploded, matter spread everywhere, then it started to cool down. Here we are in the present state. This is what happened. So a big question I am going to ask you people, that how can you prove Big Bang occurred? We are only assuming that Big Bang occurred. I will answer this question next video, but I will give you something that microwave radiation which I told you that is part of some explosion. So you research that what is that microwave radiation, and the current temperature of universe is what 3 degree Kelvin. It may be low, 2.7 degree Kelvin, and because of that microwave radiation. So let's end this video. We will be coming just 1 day or 2 day. So see you in the next video, guys. If you like the video, you can subscribe it.